Thank you, Taka, for being very transparent with your responses and your presentation, and just to define the difference between your sustainability, ESG, and CSR initiatives. So it's great to see that. Now I can officially say that Dr. Titia will come to the stage. On her panel session, she'll be joined by 3 other panelists. Again, the topic is combining decentralized and smart wastewater systems to enhance water security. So please, Dr. Titia, come to the stage, and you'll be joined by your panelists, Khalid, Hamad, and Mel. If you please join the stage, thank you.
So for round 2 now. Yeah, I will join you. I will join you shortly. So just maybe sit under your picture.
Oh, okay.
Sort of, yeah. Okay, so in the face of the growing water scarcity and climate change impact, the MENA region is increasingly focusing on innovative solutions to secure water resources, where we heard yesterday very good examples from Sheriff Mahamadi from the National Water Research Center in Egypt about nature-based solutions for decentralized solutions for remote areas, for treatment and the use for irrigation in Egypt. However, Engineer Jayatar Mapalan from Dubai Municipality presented a case that Dubai is working on implementation of sewage and stormwater tunnels to ensure future needs are met and flooding is prevented. This more centralized is also followed by our company, Taka Water Solutions, and we already have a sewer tunnel in place with a design life of 80 years. So this panel session will now delve into potential of combining decentralized and smart wastewater systems to enhance water security in this water-stressed region. By exploring the integration of decentralized systems with cutting-edge smart technologies, we aim to highlight how these approaches can play a pivotal role in improving water management, enhancing efficiency, and fostering sustainable development. So please let me welcome to my panel of specialists, and I would like them to each introduce themselves briefly.
I'm Khalid Hassan, the Regional Head of Waste Utilities in Atkins Realis. I've been working in UAE for about 18 years on both private and public sectors.
Hi, my name is Mel Meknasi. I'm the Growth and Strategy Director for the Middle East for Jacobs, for Utilities, Infrastructure and Environment, and a water resource engineer by background. I've worked in water resources consulting for over 18 years before this current position. Thank you.
Hi everyone, my name is Ahmed Abu Yusuf. I'm a sustainability specialist at Taka Water Solutions. I'm focusing on looking after the environmental pillars of our business related mainly to carbon, energy, water, and waste. My background is mechanical engineering and specializing in the waste utilities sector. Thank you.
Yeah, thank you very much for the introduction. So central versus decentral seems always to have divided a lot of engineers. Some are actively promoted central systems due to the economy of scale, where others promote decentralized systems due to local availability of the recycled resources. So I would like to start with Mel. Mel, how has artificial intelligence disrupted the established practice around the question decentralized versus decentralized systems?
So the first thing I'll say is I'm not going to lecture everyone in the room. There's a lot of brain power and experience in this room, a lot of familiar faces that have worked on this problem for many decades. So I'm sure everyone's very familiar with the trade-offs between centralized and decentralized. But I'll go a bit further than that and talk about first of all, what is established practice? So we have, for example, anyone who's worked on this problem in the last 20 years will know that it's a problem that you would spend maybe 30, 40, 50,000 hours of engineering to test 15, 20 configurations at a city scale. It's established thinking is studies that have been carried out by academics and case studies all around the world, case studies by the US EPA, IWA, by universities in the US, Brazil, India, and many other countries that are published. And they promote, these studies promote rules of thumb that I've seen referenced in planning and engineering studies for citywide wet utilities here and elsewhere. Rules of thumb such as centralized systems are efficient above 10,000 people, or decentralized systems cost 4 times as much per cubic meter treated. The reality is that it's a lot more complicated than that. It's the question that we're asking today is an optimization question, and it's a multi-dimensional, multivariate, highly dimensional, multivariate optimization problem. And these are the problems that modern artificial intelligence and machine learning are very good at solving, problems that are too complex for us as people to comprehend and to solve. So it would not have been feasible to solve for all options and find the global optimum for every city in a reasonable amount of time and cost. So if we took just a rough example, a very simple example, Sydney. Sydney is 120 kilometers by 100 kilometers. We see in this part of the world there are many centralized systems. Sydney has 8 sewage catchments and 24 wastewater systems, but over an area of, I think, 16,000 square kilometers. So is it centralized or decentralized, or is it both? Maybe it's both. One of those systems is maybe equivalent to a centralized system elsewhere in the world. So if we look at the problem, if you were to solve for one city, just for one city, and find the global optimum for that city, if you were to think of it as just mathematically, a 12-dimensional problem, and each of those dimensions only have 10 settings, 10 options, you're talking up to 1 trillion combinations. And if you wanted to solve for every one of those combinations, it would take you, even if you needed only an hour to solve every combination of those variables. They could be social. No one wants to live next to a wastewater treatment plant. So many physical, geographical, economical, and environmental dimensions, and resilience. If we wanted to solve for every one of those parameters, it would take over 100,000 years of computation time, which is not realistic and not cost effective. Whereas artificial intelligence algorithms are able to approximate a global optimum or a very, very good local optimum in a reasonable amount of time, and it's only accelerating. So that's only one way. There are other ways that it can solve. There's agent-based modeling, which is an emerging science with AI. There are other presenters in this forum that talked about prediction of rainfall using artificial intelligence, which also plays into this equation. But just to close this point off, we are at a stage now where everyone in this room has the building blocks, whereas maybe 15 years ago this would have been a PhD coding in R as part of their PhD study that we would have all followed. We have the building blocks of the most sophisticated AI optimization algorithms, open source packages like Google's TensorFlow, like Microsoft Cognitive Framework. These tools are accessible at a high school level. They're no longer, there's no longer a barrier to PhD level. So it's very easy entry for anyone here to apply those algorithms, state-of-the-art AI algorithms to solve that problem. Just to close the point, there was one sponsor of this forum that said, we are building the runway as we take off. These algorithms have not fully penetrated our industry, and we're still very early and we don't know yet how they will impact.
Thank you very much, Mel. I just want to go a little bit into the practical application of decentralized systems. So Ahmed, can you provide an example of a decentralized system for collection that did not quite have the anticipated effect, and how could this be prevented for any future project?
Well, thank you. We've had a few cases where the building of a decentralized system wasn't the best option. Now, in most cases, yeah, we can get it right by doing the right feasibility study and studying all the doing the right multi-criteria analysis, where we have to build a wastewater treatment plant. Now, there are many important factors we need to consider, and also decide on what is the importance of each one. So some of those would be basically what is the average and peak flow that we have to deal with. If it's a remote location or in an urban area, for example, the economy of scale for the treated water. We have to think about the feasibility, about the approvals from authorities for securing a new location. So there are many factors. Also, one important factor is the ease of operation and maintenance for such assets. So each system will have advantages and disadvantages when it comes to centralized versus decentralized. So we've had to deal with both cases as TACA Water Solutions historically, and also working with many developers, for the best optimum option. Also, we have to consider the carbon emissions, not only the operational carbon emissions and energy consumption, but we have to consider as well the capital carbon or embodied carbon. And we have the in-house tools, customized tools that can enable us to quantify the expected carbon emissions for multiple options, whether it's embodied carbon or operational, and we call it life cycle carbon quantification. So it's a case by case, I guess. If you want to go with the centralized versus decentralized. So yeah, I think both can be applicable.
Yeah, and also the system using AI in the future will maybe also help to get a more optimized solution that can just sort of stay in operation, and you don't have to go from decentralized back to decentralized because of the operability was not considered during optioneering of this project. So to just move a little bit to the smart part, the AI part. So currently, does TACA Water Solutions applies any smart measuring and monitoring, and what's the plan for the future?
Well, currently the application of AI is not mature enough for our assets, but we do have something in the pipeline, a recently awarded project that will utilize AI for all the running assets. So we're talking about something near 44 wastewater treatment plants and 220 pumping stations for wastewater that cover all of Abu Dhabi Emirates. So this project basically intends to use artificial intelligence as far as monitoring, controlling, optimization of the instrumentation of all the pumps, all the major equipments, whether it's inside an STP or a pumping station. So hopefully within the next few years, the system will be online, and we're expecting to have benefits related to the energy consumption, related to ease of operation, also related to carbon emissions as well with the system. So yeah, so it's coming soon as far as incorporating artificial intelligence to operate our assets. So it's a new technology for us.
Yeah, thank you very much for this. Khaled, can you elaborate a little bit on this? So what role does the smart technologies play in optimizing decentralized wastewater systems?
Yes, smart technologies play a crucial role in optimizing the decentralized wastewater system. Let me break it for you. Firstly, we can talk about the real-time monitoring, okay, using the sensors and smart meters powered by the Internet of Things technologies. Okay, this provide a real-time data such as flow rates, quality, effluent quality, and equipment conditions and these things. This will ensure that everything is running smoothly and efficiently, and also will help in the decision making to make any preventive action for the damages on the networks and this stuff. The second point, we can talk about the AI analytics, okay, of these real-time data. This will help to predict the system failures and also the required maintenance even before it happens. This will help also to take a proper decision making about the required actions for the wastewater system, the decentralized one, in more organized way. The third point, we can talk about the digital twins. When we create virtual replicas of our physical systems, these digital models, we can, the operators can test and optimize the operation of the wastewater systems for multiple scenarios, even before we implement these changes on the decentralized wastewater system. In summary, all of the smart technologies is not only will help to control the wastewater systems, it transform them into smart technologies, and also for better efficiency and sustainability in the system itself.
Thank you very much, Khaled. And to stay with you, we just heard we talk about the solutions. We don't really have any these smart solutions in place yet. So what do you see as the main challenges for implementation of these systems?
Yes, there is key challenges to implement the smart technologies in the decentralized system. The first challenge for sure is the capital cost, and this can be mitigated to have a phased implementation strategy. We can start with a pilot project. We can apply it on only the trunk lines, and then we expanding these systems on the lateral networks and so on. This will spread out the investment on the smart technologies on the decentralized network. The second thing, the lack of awareness. I think most of the stakeholders are not aware about the benefits and the potential of smart technologies in the wastewater system. For a long time, for example, gravity networks and this stuff is very, very minimal controls and the sensors can be applied to them. But if we have a proper training program for the stakeholders and even the private sector, the developers, this will help to have a greater adoption of these technologies. Also, lack of a skilled workforce. Okay, we need to have a training program for the engineers and operators to know how to handle these new technologies. Okay, and the last thing for sure is the cybersecurity. Okay, because we know that all of these smart technologies will be on a cloud-based IT infrastructure. So we need to have a robust cyber technology framework to help securing this real-time operational data on our system. So as a summary of this, I think we need to prepare like a standardized digital infrastructure guidelines. Okay, this will provide a clear framework for the stakeholders, for the developers, of how to implement these smart technologies, okay, and also how to operate them.
Thank you very much for this elaboration. Mel, what do you see are the future trends in technology and urban planning with further disrupt established practices and current thinking on this subject?
So firstly on urban planning, there is a modern redefinition of what a city is today, and you can see that the Middle East is at the forefront of that redefinition. You can see that exemplified by developments here in Abu Dhabi, like Masdar City. In Dubai, you have Expo City. In Saudi Arabia, you have NEOM. the trend is towards mixed-use communities and away from very rigid one land use type zoning, where you can live a very high quality of life within walking distance and a sustainable lifestyle within walking distance of your home, your work, your education, healthcare, and entertainment and all of those aspects. And so that leans more towards a mix between, it moves away from exclusive centralization towards a mix of managing energy and water and circular economy at the community scale. It's not a full shift towards decentralization, it's more of a mix between centralization and decentralization. That's the first thing. On the technology side, Khaled, you mentioned digital twin. So a lot of people I hear speaking about digital twin these days as if it's a product or a service that you can opt into, that you can buy. The reality is it's happening whether we like it or not. So the trend of our infrastructure existing physically and digitally, in the physical and digital realm simultaneously, is another trend that will push and overcome the challenges of decentralization and move towards a shift towards more mix of centralized and decentralized infrastructure. So if I can give an analogy, a lot of the people in this room will have a digital twin. You have a digital twin of your personality, of your identity, of your tastes, through, if anyone has social media, if anyone has ever filled out any data for a bank or for a purchase, that data is used to predict your tastes. Advertisers are very, very good at using that data and understanding what you would like to buy and how much you're willing to pay for it. So in effect, we all have a digital twin. We all exist digitally to some extent. Our personality and our identity exist in the digital realm. As that starts to happen more with infrastructure, what that means is we're going to have a lot more live information, and we'll be able to interact with our infrastructure a lot more, and that's ripe for the application of technology. And so that will make, again, I won't say a push to decentralization, but it will facilitate a move away from exclusive centralization towards the global optimum for every city, wherever that may be, whatever that mix may be.
Yeah, thank you very much, Mel. So if you have to start from scratch, then AI can be of great help to identify what is the best direction for your situation.
Yes. And another thing that we need to be careful about is that we still don't know what that global optimum is. So we need to be very careful to future-proof infrastructure today so that when it is defined, our infrastructure can be adapted cheaply and quickly towards whatever we find out to be that global optimum.
Yep, so also I would like to give the floor the opportunity to ask any questions or to add any ideas that they have on this topic. I see somebody here. The microphone shall come to you.
So my name is Rob Roo from DMT, and thanks for very interesting discussion. My question is actually from the point of the downstream network of the treated wastewater, or you call TSE. We are somehow experiencing a kind of high salt content in the TSE, and that means water, treated wastewater, could not go into the irrigation directly. You have to further treatment. So in this case, how could you use that smart wastewater system in helping to cope with this kind of problem? Because we are talking about sustainability and further use of this treated wastewater. Thank you.
Ahmed, are you taking this?
Sure, yeah. I mean, for any, well, first of all, we stopped calling it TSE a long time ago. It's recycled water now, as imposed by our regulator. But yeah, at the outlet of every wastewater treatment plant, I mean, that's even the current practice, that there's a sampling that takes place for the recycled water in terms of the septicity or the presence of metals or any other microorganisms. So basically, based on this analysis that's done on a daily basis, you can see if there's something that is beyond the approved parameters by the regulator. Then we need to either divert it or do some modification within the process in order to mitigate whatever high sulfur or high salinity that you referred to. Now, this problem would be like in maybe a few locations, but not everywhere. So currently, yes, you know, if there's something that's out of the required approved parameters, then yes, we can address it immediately when it happens. And I'm sure that AI would add value to this, maybe make it more faster response time, you know, once it's active.
Yeah, I think we can add to it that there's a few pilot projects going on, which having probes in different places in our network, and they will send via the mobile phone network, like actual data in the network. And also we have this sewer bowl project, and they will actually identify where you have this groundwater intrusion or high TDS level or any wastewater entering the system that's not compliant to the sewer. So, and this will also be linked to the SCADA AI in future.
So yeah, so we have standards actually for the influent, meaning the water that's entering the wastewater treatment plant, and we have standards or parameters for the recycled water or TSE. So in both cases, we have to abide by for both. And like Dr. Titia mentioned, this is on the upstream part, where we have to monitor the wastewater and then pinpoint any location where we might have, you know, heavy metals or any higher rate of salinity, which we need to address at that specific location. Then we can isolate it and, you know, and address that problem, and then divert the flow until the work is completed.
Yeah, prevention is better than to cure, right?
Correct, yes.
Khalid, can you add anything?
Yeah, I can add something that about he talked about the quality of the recycled water. I can take to the root cause of this, and if we have our smart sensors spread around the networks, this will enable us to define exactly where is the illegal water discharge happening, whether it's high in saline or high in even sometimes chlorine, some swimming pool illegal discharge without following the proper procedure. So we can define exactly where is this location, and we have early warning, and we can take preventive actions against these kind of incidents before the full water reach the STB, especially if it is decentralized. For example, a small community or something, if one person decides to just discharge his swimming pool to the system, it may damage the STB. So if we have the early warning and alerting the operation maintenance, okay guys, so they will go and take preventive action and protect our STB to make it operational efficiently, and there is no downtime and so on.
Yeah. Mel, can you add anything?
So this is a fantastic example that's relevant to here for this subject. If you have saline water coming from a centralized system, is it better, is the optimum to treat it at a centralized level for all recycled water, or is it more efficient to treat the water locally for every user based on their water quality requirements? If you're treating at source, you have to treat for all the users that may possibly want to use that water. If you're treating at use point, then every user is responsible for their own treatment, and it becomes a distributed problem. So centralized versus decentralized. And the answer, again, is probably somewhere in the middle. The other point about this problem, which makes it interesting, is, like you say, it points out that infrastructure now exists in the digital realm. Once you plug sensors to the system, you have live data streams of salinity entering the system. You can tell whether it's happening when it's raining, whether it's happening on Fridays when the system flows are different. And an algorithm hooked up to those live feeds would not simply look at it the way that we would in a spreadsheet figuring out that maybe this catchment is giving the higher salinity. An algorithm, a classification algorithm, for example, would look at it and think, well, the salinity is coming from catchment X. Most of the pipes in catchment X were installed 20 years ago. Half of them were installed by this contractor. And my O&M system is showing that there's a correlation between those factors and failure in that material, in that size of pipe installed by that contractor. And therefore, not only do I predict salinity where I have a sensor, but I can extend that to areas where I don't have sensors.
Just one last point related to this, to having a better quality recycled water from the wastewater treatment plant is, I guess, moving towards the non-centralized approach. So I think this will help of having a shallower network, which would be easier to operate and maintain versus having a deep, vast network that will take all the wastewater to a central treatment plant. So I think going with a decentralized approach would limit or mitigate, having infiltration into the network, whether it's illegal discharge or high septicity into the network. So I think that would be a good thing to consider in the future, that not everything has to go to a centralized location.
Yeah, thank you. Any more questions?
Good morning. First of all, thank you very much for useful discussions to the panelists. A lot of insight, much appreciated. I've got a question. So my name is Henry, I'm from Morale, developer. Just wanted to understand, right, we've discussed monitoring, we've discussed, how do we kind of understand that there's a problem, but how did we tackle future-proofing? The reason why I'm asking this is, if you're a developer, you have to comply with the codes, right? I think you guys already spoke about the quality of the wastewater. It's all regulated by the Trade Effluent Control Regulation, and that's great. It even explains that if a developer or an owner of an asset does not comply with it, they will potentially be fined up to 10 million dirhams, right? So understand there's a big motion to comply with all the regulations, which is total dissolved solids as an example, which is the salinity levels. These are the high indicators which I believe you guys are currently really trying to monitor and understand what's going on there. But how do we avoid this happening on future developments? At the moment, as a developer, you get a consultant. The consultant designs the sewer system based on the Uniform Plumbing Code of Abu Dhabi, which is developed, I don't even know when, a couple of decades ago. And then we also have the, we've got the STDAMA requirements. And between those two, you try and develop this against a fast-paced life, a fast-paced program, and then you get to the end, and then you get the regulator, which comes and gives you a little bit of a tickle if you're above the requirements dictated by the Department of Energy. Fully understand that. But there's not a clear bridge for me in terms of where the codes, which developers and consultants use in this region, marries up with the regulatory requirements on the wastewater discharge. So how do we bridge that gap, and what is currently being done in the region to kind of support consultants and developers to be aligned with the direction to support recycled water?
Okay, thank you. I'll try to make this answer brief since we run out of time. Well, the Unified Plumbing Code, which is followed by Abu Dhabi municipality, is related to building services. Now, we're talking about the underground, wastewater infra. So we have our own standards when it comes to the procurement, installation, testing of all the wastewater assets. The Unified Plumbing Code, again, is for the building services, for plumbing works, which would not be an issue when we were trying to prevent illegal discharge or underground infiltration. So to bridge the gap, so basically when any developer has a new project, basically we review the master plan, and we make sure that we ask for the parameters that will be discharged from this development. It could be like entertainment, for like a sea world, for example, kind of thing, where you might have a high concentration of salinity or other materials. So in this case, the developer is obliged to have a pre-treatment before discharging into the main utility network, which is operated by Taka Water Solutions. So this applies also to manufacturers or whoever cannot, let's call it non-domestic quality of wastewater. So I think following the standards, standards and specifications and guidelines set by Taka Water Solutions, which would be applicable from the chamber right at the plot boundary. And also, like I said, to have a pre-treatment, could be chemical, could be physical treatment, if you cannot comply with the regulatory requirements in order to protect our assets from, from corrosion, from excessive odor. So, yeah.
Yeah.
Want to add something?
Okay, thank you. Maybe more discussion during the break. So yeah, we're out of time. I was going to ask central versus decentral, but I think we have sort of a general consensus reached that it will not be one solution fits all. It will be always a combination of either one of them, and AI and smart solutions will help us in the future to make the best decision going forward. So thank you very much, dear panel, and yeah, more discussion in the break, hopefully.
Thank you.